Okay, this is McGraw-Hill Chapter 3, Section 5, deals with systems of equations and graphing inequalities in two variables. All right, example 1, first of all, we've got to be able to draw a line. So the first thing we do here on this particular problem is it wants us to graph negative 3x plus y less than or equal to 1. Well, we add the 3x over, so we get y is less than or equal to 3 over 1x plus 1. Remember, I'm putting the slope in a fraction because the top number tells us how to move up or down. The bottom number always tells us to move to right. So I plot my 1. There's my y-intercept. Slope tells me to go up 3 and over 1. There is my second point. Now, here's the thing. This is saying we want all the y's less than or equal to the line. So less than or equal to, whenever I have less than or equal to or greater than or equal to, it's a solid line. And whenever I have less than, then I want all the y's, I want to see where the line crosses the y-axis. And if I'm less than, I'm shading everything below the line. Because what this is doing is telling me that they want all the y's below the line. If it's greater than, we want all the y's above the line. Here's example 2. We have negative 4y is less than or equal to 5x. Divide the negative 4 over. Remember, whenever we divide or multiply by a negative, we've got to flip the sign. So this becomes y is greater than negative 5/4 x plus 0. And I always put it in slope-intercept form. So my y-intercept is 0. I'm coming down 5 and over 4. There's my second point. Because this is greater than or less than, it's a dashed line. And because we're looking for all the y's greater than the line, here's the line. The y's greater than the line or the y's above the line. So that's how we're shading that. Here's example 3. In example 3, we have 4x greater than or equal to negative 12. Divide both sides by 4, we get x is greater than or equal to negative 3. So this is a vertical line. So we go to negative 3, draw our vertical line. It's a solid line because it's greater than or equal to. Because we want all the x's greater than the line, we're looking at the x-axis. All the x's less than the line are to the left. All the x's greater than the line are to the right. That's the reason we shade the right here. Now we come into a system of inequalities. So here we're graphing two equations with the word and. Remember, the word and means intersection. So the first one we don't have to change, it's already in slope-intercept form. It says y is greater than 1/2 x plus 1. There's my 1. I'm going up 1, here I'm going over 2. There's my line. It's a dashed line, and I'm shading everything above it. This one I have x plus y is less than 1, so I subtract the x over. It gives me y is less than negative x plus 1. So again, my y-intercept is 1, but this slope is negative 1 over 1. So I go down 1 and to the right 1, dashed line, and I'm shading everything below it. So the first line is the blue, which is shaded above. The red line is right here and shaded here. Because it's and we're looking for the intersection, this is our solution right here. It's where the blue and the red come together. There's another system of inequalities with the word or. Now remember, the word or means all possible values, just don't repeat any. So here we have 3y less than or equal to 6. Divide both sides by 3, we get y is less than or equal to 2, which is a horizontal line, a solid line. So here's our horizontal solid line at 2, and it's shading everything below it, because we want all the y's less than the line, which are below. Here, we have y minus x less than or equal to 0. Add the x over. We get y is less than or equal to x plus 0. So our y-intercept is at 0. We go up 1 and over 1. There's our second point. Line solid, and we're shading everything below the line. Now because it's or, our graph is actually all of this up here. If it were an intersection, it would just be this area here if it were and. But because it's or, it's everything that we have here shaded.